Hey guys, today I'm going to teach you how to do the Lewis dot structure. So first we need our periodic table. So I need you guys to remember that this is group 1A, 2A, skip the transition metals. This is 3A, 4A, 5A, 6A, 7A, 8A. So basically that tells us how many valence electrons, the electrons in the outermost shell, an atom would have. For example, fluorine is in 7A group, so fluorine would have 7 valence electrons, and carbon is in 4A group, so it should have 4 valence electrons. Beryllium right here is in 2A group, so it should have 2 valence electrons. Now let me show you how to write the Lewis dot structure. Is basically all you need to know is the number of valence electrons. Okay, so let's try lithium. Okay, so lithium is in group 1A. So when you write lithium's Li, the Lewis dot structure would be just 1 electron because lithium is in group 1A. Okay, so now beryllium or magnesium, let's do magnesium. Magnesium is in 2A. So magnesium, when you write the Mg, and since it's in 2A, it should have 1, 2 electrons. Next one, we're going to do boron. Okay, boron is in 1A, 2A, skip the transition metals again, and this is 3A. Okay, so 3A boron would have 3 valence electrons. So B, so top, bottom, and left. So you have 1, 2, 3. Let's do another one. Carbon. Carbon is in group 4A. So when you draw the Lewis dot structure for carbon, it should have 1, 2, 3, 4. Okay, this is dot, not a dash. So nitrogen. Nitrogen is in group 5A. So nitrogen is in, since this is in group 5A, so it should have 5 valence electrons. So the way you write the electrons would be top, bottom, left, right, and then pair up clockwise. Okay, so this is the 5th electron. So you see 1, 2, 3, 4, 5. Another one we would do oxygen. And oxygen is in group 6A. So it should have 6 valence electrons. So 1, 2, 3, 4, 5, and 6. The next one we would do would be fluorine, and it's 7A. So fluorine would be F with 7 valence electrons. There's 1, 2, 3, 4, 5, 6, and 7. Okay. The next one is neon. So neon is in group 8A, so it should have 8 valence electrons, which is a noble gas. So neon is a noble gas. It has octet already. It has 8 valence electrons, so it's very stable. So there's 1, 2, 3, 4, 5, 6, 7, and 8. So 1A has 1 valence electrons. 2A has 2 valence electrons. Skip the transition metals. 3A with 3 valence electrons. 4A with 4. 5A with 5 valence electrons. 6A with 6 valence electrons. 7A with 7 valence electrons. And 8A with 8 valence electrons. Now let's try to do, so this is individual atoms, okay? So let's try to do and draw the Lewis dot structure for methane, which is CH4, okay? So just remember that hydrogen can only hold 2 electrons and carbon can hold 8 electrons, okay? So let's start it one by one first. I'm going to start with carbon. So carbon is our central atom because it is the only one. There's 4 hydrogens and there's 1 carbon. So you would write it as C. Oops, let me just erase that. Okay, so CH4. So carbon has, since carbon is in group 4A, so it should have 4 valence electrons. So there's 1, there's 2, 3, and 4. Okay. Hydrogen is in group 1A, so it has 1 valence electron. So it would be H. There's 1 H. We need 4. There's another H, another H with 1 electron, and another H right here with 1 electron. So then C is a non-metal, and H, which is in 1A, but is actually a non-metal. So when non-metal and a non-metal bond together or interact together, they would form a covalent bond, which means that they are sharing electrons. So this is letter H. So these 2 electrons are going to bond together and share electrons. So now we have hydrogen has 1, 2. Hydrogen is happy. This hydrogen right here has 1, 2, so it's happy. 1, 2, again, this hydrogen is happy. This hydrogen here has 1, 2 electrons. Now carbon needs 8 electrons to be stable. So we have, since this is shared, so this is 2, 4, 6, 8. So carbon is also happy. So when you make your ball and stick model, it's going to look like this. So for example, your C is, so when you have your, when you draw or you're going to make your Play-Doh, say you want this to be red and you want your H to be blue. Okay, so then this is how you're going to make your model. So in the middle, you would have your red, which is carbon. And then this is going to be your Q-tip. Q-tip here, Q-tip here, and your Q-tip here. And then you're going to have, this is your blue Play-Doh, which would tell you that that is your hydrogen. And that's it. It's very easy. So let's do another one. Let's try oxygen gas. Okay, oxygen gas is O2. And looking at our periodic table, oxygen is in group 6A, which should have 6 valence electrons. And this number 2 right here is going to tell us that there should be 2 oxygen. Okay, there's 1 oxygen. There's the other oxygen. This right here is 2. So oxygen is in 6A, so it should have 1, 2, 3, 4, 5, and 6. Again, this is oxygen, so it has 1, 2, 3, 4, 5, and 6. Now, oxygen needs 8 electrons in order to be stable. Okay, so what we can do is this, actually I'm going to move this one. This and this would form a bond, and then this and this would form a bond. So now we'll erase this one right here. Okay, so that's gone. So now let's count. 2, 4, 6, 8. So this oxygen is happy. 2, 4, 6, 7, 8. But what we can do is pair these two together. Okay, so we can put it right here. And you can move electrons around. Okay, so the goal is to have 8 electrons for them to be stable. So there's 1, 2, 3, 4. A single bond is 2 electrons. So there's 2, 4, 6, 8. So this oxygen is also happy. So when you make your model, it's going to look like this. Since O is both oxygens, so your key or legend would be oxygen is, say, orange. Okay, so this is when you make your Play-Doh orange. And so then the way you make that is you have your oxygen Play-Doh. And then since you have 2 bonds, then you would use 2 Q-tips. 1 Q-tip, there's the second Q-tip, and there's the second oxygen. And that's it. Simple, right?